The next thing we want to consider is how to deal with positive charges. So say you have a molecule like CH6N+, and as it's written, we really don't know where the positive charge is at on the molecule. So the general way we'll deal with this when we draw the Lewis structure is a positive charge means we've lost one of those negative particles. We've lost an electron. So remove one electron from a central atom. So let's do that. And if we're going to draw this, we might do carbon and give it 4 electrons. Nitrogen has 5 electrons. And let's say you decide, I think I'll remove the electron from the carbon. So let's cross this one out and say it's no longer there. Now we need to put our hydrogen in, and we have 6 of those. So let's put those in. I'll go ahead and connect the carbon and the nitrogen here. So if we put our hydrogen in, there's 1, 2, 3, 4, and you're stuck. You can't go any further. So if that happens, basically say that's not going to work, and try taking an electron from a different atom. So what if we take an electron from the nitrogen instead? There's carbon, nitrogen, and take the electron from the last place it was put in. So the last one that was put in was the lone pair. So we'll get rid of one of those electrons in the lone pair. Now we can connect the bonds. Let's put the hydrogen in. There's 3, 4, 5, and 6. Connect those up. And that works. So let's clean this structure up a little bit. We have a CH3. NH3. Now, the nitrogen doesn't have its typical number of bonds. Usually nitrogen wants 3 bonds. Now it has 4 bonds. A general rule of thumb, when an atom has an unusual number of bonds, it will carry a charge. And we do have a positive charge we need to put on this structure. So we're going to put the charge on the nitrogen. Later on, we're going to learn how to calculate formal charge for the atoms. So now let's look at how we deal with a negative charge. And for it, it's the opposite of what we did with positive charges. Instead of removing an electron, we add an electron to a central atom. And when I say central atom, it's not that it can't be at the end of the molecule, it's just one of the atoms that can form multiple bonds. So don't try to add the electron to a hydrogen or a halogen. So with this one, we have C2H5O. And again, there's a couple ways you might connect these. And more than one way can be valid. But let's say we just put the 2 carbons in a row, followed by the oxygen. And now we need to add an electron. And you can add this electron to any of these atoms. And after we finish this example, I would encourage you to try adding it to one of the other atoms. But let's say we decide to add it to the oxygen. So if we add it, we'll form a pair. Now we need to connect our bonds. Connect those. Put our hydrogen in, we have 5. 1, 2, 3, 4, and 5. And then we'll connect these bonds. So now the oxygen, it still has its octet of electrons, 2, 4, 6, and 8. But it doesn't have the 2 bonds that it typically wants. Because it has an unusual number of bonds, it's what is carrying the negative charge. So we'll put our negative on the oxygen. Had you added the extra electron to one of the carbons, then you would end up with an electron pair on the carbon, and it would bear the negative charge.